In this video, I wanted to show a data visualization. Again, this one's about fish. I like fishing, so there's a lot of my visualizations are related to fish data. But I wanted to show, in this particular visualization, a concept about adding analytics or an analytical insight to a visualization. I see a lot of times that vizzes that are presented are basically taking data and kind of regurgitating it, putting it into a nice form for people to navigate and look at, but they don't really add value to the data, meaning that they don't necessarily process the data through some model or analytical function to add some element of understanding to the data that can drive an insight. And this is a relatively simple example, but I wanted to show this as just a concept here. You know, the top section, I'm showing the state records for largemouth bass and the location where that particular fish was caught within the state. So this is interesting in itself, and you can kind of filter down, and you can see the star is where the U.S. Entire country record is. In this case, for largemouth bass, 1932, 22 pounds in Georgia. So that in itself is interesting. I think a lot of people would think that would be a decent visualization. But in addition to that, what I did is I was interested in seeing the concept is if you go further south, potentially you have a longer growing season for bass, maybe that they get larger, and you can see that it is very significant. This trend line that's here, p-value, seems to be very significant. Would indicate that as you move north, every 1 degree of latitude, the state records drop by about half a pound, and it would indicate that these states down here, these like northern zone states, are the ones that are significantly disadvantaged in trying to catch, let's say, a world-class largemouth bass. And you can then look across multiple different kinds of species. In the case of smallmouth bass, the p-value is not significant. You're not seeing much of a difference. It doesn't really seem to matter. It's Michigan actually. I mean, Tennessee is definitely out here with the U.S. record, but Michigan at 9 pounds versus Alabama at 10. Not to say that Michigan couldn't potentially have a fish that starts to rival some of these southern states. So smallmouth don't seem to be as affected. White crappie, on the other hand, seems like the further south you go, and it is significant, not as much as largemouth bass, and we seem to have some outliers here. But it looks like as you move up, the weight difference is smaller, but then again, white crappie are a smaller species in general. Yellow perch, interesting, that the further north you go, you're actually seeing New Jersey here with the U.S. record, but it seems like the further north you go, you actually have a better potential opportunity of catching a larger yellow perch. Walleye, let's take a look at walleye. Not significant, but it does look like some of these northern states are doing a little bit better, but again, it's kind of mixed, so and it's not significant, so nothing that's a 100% trend on the walleye. And then bluegill, we'll take a look at bluegill records. It's not significant, and we have a lot of things that are outliers here. The one that seems to be the most consistent is this nice kind of really tight distribution on the scatter plot. But I wanted to show this as a view to kind of get an idea of how to design something that involves a little bit of it's a very simple model. It's a really simple regression model, and it only has x and y axis, and really is only using one variable on it. But if we take a look at what you could do, you could look at something like this, which you might see as a data visualization that shows you, well, here's the records, and you can pick a fish and you can see it kind of in a table format. This is maybe aesthetically pleasing. It's not really that it may be cool to navigate and really quickly look at the information, but I think that adding these analytic values is really what businesses are looking for when they talk about analytics and the power of analytics and adding that into modeling of data. So wanted to show that as a combination of visualizing data and adding value through an analytical function.